Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss chemistry for IIT, JEE, NEET, class 11th and 12. Particularly we'll discuss organic chemistry. Our mission is to provide free classes on YouTube for all the students for class 6 to 12th and for students who are preparing for IIT, JEE, NEET, ND and other competitive examinations. Before we start, we request you to subscribe, like, share, and comment on our YouTube channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Please comment if you need on the comment box if you need any specific video for any subject or any chapter. We'll try to create it as soon as possible and as soon as we get the request. Now let us see the lesson. So first we'll do the introduction. First question which comes to our mind is how the elements were formed. So they were formed 14.5 billion years ago, the when Big Bang took place, and hydrogen and helium, the lightest element, were formed. After this phenomena, further nuclear reactions in stars transmuted these elements into heavier ones, including carbon, nitrogen, sulfur, oxygen, phosphorus, and most of the elements of the periodic table were formed. After the massive explosion called supernova scattered the elements in the universe over the time into different planets. And over the time, small molecules, organic molecules were formed which can support the life. For example, nucleic acid, from which DNA and RNA is made up of, amino acid, which comprises protein, carbohydrates such as glucose and other types of molecules were formed. In this way, all the elements and molecules and also the organic molecules were formed. In the early 19th century, scientific, scientists classified all the known compounds into two categories: organic compounds, which were derived from the living organisms like plants and animals, and inorganic compounds, which were derived from non-living sources like minerals and gases. This distinction was made because organic compounds properties was dissimilar than that of inorganic compounds. Organic compounds were often difficult to isolate and purify. Upon heating, they decomposed and more readily than inorganic compounds. To explain this curious observation, many scientists started believing that organic compounds obtained from living source possess a special vital force than that of inorganic compounds. This belief was known as vitalism. In 1828, German scientist Friedrich Wöhler demonstrated and that from inorganic compounds we can create organic compounds. So he demonstrated an experiment. Ammonium cyanide, he have taken ammonium cyanide, which is an inorganic compound, and heated it, and the product what he got is urea, which is a organic compound. This experiment was very important because it rejected the theory of vitalism. Before that, it was believed that we cannot create any organic compound from any inorganic compound. In mid 19th century, three individuals working independently led to the conceptual foundation for structural theory of matter. August Kekule, Archibald Scott Cooper, and Alexander M. Butterlove each suggested that substances are defined by specific arrangement of atoms. They have taken the example of the same experiment from Hooler. So here we can see that the molecular formula for both ammonium cyanide and urea are same, that is NH4NO N2O, but the structural formula are different, and so their name and properties are different. As a result, they are called constitutional isomers. Constitutional isomers having different physical properties and different name. Now let us see one more example. So dimethyl ether and ethanol are formed from a molecular formula C2H6O, where the boiling point of dimethyl ether is minus 23 degrees centigrade and boiling point of ethanol is 78.4 degrees centigrade. Dimethyl ether is in present in gaseous form in room temperature. Ethanol is present as a clear liquid in the room temperature. In this way, we can say the physical property and name are different for these two compounds. So these two are also example of constitutional isomer. Now let us see what are isotopes. Isotopes are elements which are have the same atomic number but different atomic masses. For example, carbon is present in three forms. One uh, whose mass is carbon 12, 12 other mass is 13, and the last one mass is 14. So carbon is present in three isotopes. Why they differ in mass? Because the electron and proton in those atoms, the number of electron is equal to the number of proton. But in the nucleus, the number of neutron increases. Therefore, uh, due to the increase in number of neutron, isotopes are formed. Similarly, we can take example of uh, nitrogen. It has two isotopes, that is two stable isotopes, that is 14 and 15. 15. Now let us try to understand what is valency. Valency describes the number of bonds usually formed by each element. For example, carbon can form 4 bonds, so it is tetravalent. Nitrogen can form 3 bonds, so it is trivalent. Oxygen can form 2 bonds, so it is divalent. And hydrogen and halogens can form 1 bond, so they are monovalents. Now pause your video and please proceed with these questions. If you have any difficulties, please write a comment on the comment box. I'll solve it for you. But remember, don't proceed before solving without solving this two questions. So first, what are bonds? Bonds are electrostatic forces by which two atoms are attached together. First, Gilbert Lewis from University of California defined the covalent bond as a result of two atoms sharing a pair of electrons. He had shown this with a small explanation of hydrogen atom. When two hydrogen atoms comes closer and they form covalent bond by sharing the pair of electron. In doing so, minus 433.36 kilojoule of energy is absorbed. While formation of covalent bond, three types of forces acts. First is the repulsive force between the two nucleus, the first force. Second force, the yellow one, is also the repulsive force which acts between two, two electrons. The third force is an attractive force which is given in green, which acts between the nucleus of one hydrogen atom to that of the electron of other hydrogen atom and vice versa. So this force are the attractive force. As a result of this force, as the net force is developed as a attractive force. As this as the two hydrogen atom comes nearer to the each other, these net force increases and a time comes when the attraction force overwhelm the repulsion force, repulsive forces. At that time, the intermolecular distance between intermolecular distance between these two atoms are 0.74 angstrom and potential energy is loses by 436 kilojoule per mole. In this way, both the hydrogen atom are in stable state. Now, let us do an example. The question is, draw the Lewis structure for boron and nitrogen. So, we know the boron, the periodic table position for boron is group 3a. That means boron have 3 valence electron. So Lewis dot structure for boron will be, the symbol is B, therefore this way. Similarly, if we know that the similarly we know that the uh, position of nitrogen in a periodic table is group 5a, therefore it has a 5 valence electron, therefore its Lewis dot structure will be like this. Let us do one more question example to find Lewis dot structure for CH3F. So first is we will find the total number of valence electron in the compound. So C have 4, hydrogen have 1, so it will be 3 multiplied by 1, and fluorine have 7. We add it. Upon adding this valence electron, total number of valence electron is 14. Now let us form the bond. Since carbon will in the middle, it has 4 valency, so in each with each valency it will with which valence electron it will share with hydrogen, 3 valence electron it will share with hydrogen to form 3 covalent bonds, and 1 it will share with fluorine to form a bond. But here hydrogen is stable now by getting the helium configuration 2 by sharing electrons with carbon. Carbon is also stable, having 8 in the valence electrons, sharing the 3 sharing with 3 hydrogen and 1 fluorine atom. But fluorine has only shared with 1 electron. Its 6 electrons are left. So we'll draw these 6 electrons which are left. So this is the complete structure, Lewis structure for CH3F. Octet rule. So what is octet rule? The tendency of an atom to achieve a configuration where its valence shell contains 8 electrons is called octet rule. So few of the Lewis formula we have seen just now. So all the elements were trying, except hydrogen, were trying to get a 8 in its valence shell by sharing the electrons to get this to get a stability. But hydrogen is exceptional. It was trying to get 2 electrons on its valence shell to get its stability. So this is called the octet rule. So till now we have done the covalent bond. Covalent bonds are, and simply we can say covalent bonds are formed by uh, sharing of electrons. Ionic bonds or electrovalent bond. Electrovalent bonds are formed by transfer of electrons. So beside covalent and electrovalent bonds, we have one more bond that is called polar covalent bond. Here, what happens? The sharing takes place first, but the shared electron are shifted towards one of the particular atom. So, forms a partial delta charge, delta positive and delta negative charge in the atoms of the molecule. So this type of bond is called polar covalent bond. We'll study in details. So formal charge. A formal charge is associated with any atom that does not exhibit the appropriate number of valence electrons. When such an atom is present in Lewis structure, the formal charge must be drawn. So let us take an example. So in this molecule, we can see that hydrogen has completed its duplet, and duplet means 2 and got the helium electronic configuration of helium. Similarly, carbon also completed its octet by sharing 4 atoms with hydrogen, oxygen, 3 hydrogen and 1 oxygen. But oxygen cannot complete its octet. It has only 7 electrons, 2 shared one and 5 unshared. So it has a negative charge. This negative charge is called the formal charge. Similarly, take one more example. Let us take one more example. Formation of ammonium ion. So nitrogen have 5 electrons because it is in group 5. So 1, 2, 3, 4, 5, 4 hydrogen. So 1, 2, 3 and 4 hydrogen. It creates a bond with 4 hydrogen. So one bond, so pair, each bond represents a pair of electron. So nitrogen has completed its octet, but it has one electron left. So this creates a partial positive charge in nitrogen. So this is called the formal charge. Before proceeding forward, we request you to stop this video and do these sums, do these problems, and if any problem while doing these questions, please write a comment on the comment box. I'll provide the solution for those. So now we'll study electronegativity. The simplest definition for electronegativity is the ability of an atom to attract electrons. That's it. Now we'll study how covalent, polar covalent and electrovalent or ionic bonds are defined in terms of electronegativity. So there can be 3 conditions. If the difference in electronegativity of the two atoms which are forming a bond is less than 0.5, then the electrons are considered to be equally shared and therefore covalent bonds are formed. Example, you can take carbon-carbon bond and carbon-hydrogen bond. Here in both the cases electronegativity is less than 0.5. So covalent bonds are formed. If the electronegativity of the two atoms which are forming bonds is in between 0.5 to 1.7, then the polar covalent bond are formed. So here covalent bond, and here polar covalent bond. And example of this can be taken as carbon and oxygen, where oxygen is significantly more electronegative, that is 3.5. Oxygen electronegativity is 3.5, carbon's is 2.5, and the difference is 1. So 1 is greater than zero point 0.5 and it falls between and less than 1.7. Therefore, the bond which formed between carbon and oxygen is a polar covalent bond. And due to this high electronegativity of carbon, the shared electron is shifted towards oxygen because the electronegativity of oxygen is 3.5, and a partial, so we can show this as a shift, which is called induction. The withdrawal of electron towards oxygen is called induction, and a partial positive charge is developed in carbon and a partial delta negative charge is developed in oxygen. Now let us study the third case where the electronegativity is greater than 1.7. Let us take an example of sodium hydroxide, formation of sodium hydroxide, where a plus positive ion form in sodium and a negative ion form in hydroxide. And this is a complete shift of electron from sodium to hydroxyl ion. Therefore, this type of bond is known as ionic bond, or it is also called electrovalent bond. Here, in this case, the electronegativity, the difference in electronegativity between sodium and hydroxyl ion is greater than 1.7. Now let us see an example. Consider the structure of methanol, identify all the polar covalent bonds and show any partial charges that results from inductive effects. So structure of methanol is given. Now we have to answer these questions. So first of all, the polar covalent bonds. So these two are polar covalent bonds. Why? We have oxygen whose electronegativity is more than that of carbon and hydrogen. So the shift of the electron will be more towards the oxygen atom rather than carbon or hydrogen atom. So two polar covalent bonds will be formed. Polar covalent bonds will be formed. And the inductive effect. So to show the inductive effect, how the inductive effect will be? The shift will be towards the oxygen atom, so it will be drawn in this way, and due to this inductive effect the partial charge will be formed here At oxygen will have delta minus, carbon will have delta plus, and hydrogen will have also have delta plus. Few compounds do not follow octet rule. They have more than 4 covalent bonds and more than 8 electrons to accommodate. For example, PCl5 and SF6 are the exceptions of octet rules. Let us practice few more Lewis structure. So now write the Lewis structure for sulfate ion SO4 2 minus. So first step, what we'll do, we'll calculate the total valence electron. So here 2 minus charge is equal to 2 electron, that is also a valence electron. So sulfur valence electron is 6, oxygen valence electron is 6, but there are 4 oxygen, so 4 multiplied by 6 plus 2 for 2 charge. So this will give 32. So valence electron is 32. Now if we consider that sulfur will make a single bond with all the oxygen atom, so only 8 atoms of sulfur are consumed, so it will not be the case. So what we need to draw, we will draw the double bond, a mixture of double bond and single bond. So we can write oxygen in all the cases here. So the oxygen which forms single bond will have 6, will have 6 here, and the oxygen which form double bond will have just 4. And this -2 charge will be shown here, not inside the compound. Now atomic orbital. In 1924, French physicist Louis de Broglie suggested that electrons form like wave-like properties. Electrons have wave-like properties, and after that, Heisenberg proved mathematically that the derived mathematical equations for this wave wave-like structure of electron, and this was called wave mechanics or quantum mechanics. Though it is not our subject area, few things we need to remember. An equation is constructed to derive to or describe the total energy of hydrogen atom. This equation was known as wave equation, and psi 1 psi 2, so first wave equation. Second, this is the energy which was derived in the form of equation, is called wave equation, and wave functions. Wave functions were psi 1, psi 2, psi 3. These are the these were called wave functions. And one more thing, that psi square. Psi square was the probability of finding the electron in that area. So these were the three important things regarding electrons as a waveform. So now we have drawn the s orbital. This is s orbital. This is py orbital, py, and this is px orbital, and this is pz orbital. So these are the three orbitals. So orbital, what are orbitals? Orbital are the region or space that can be occupied by the electron. So for example, atomic orbitals are spdf orbitals. So in this case, this joint for px this is called node, and this is the positive, and this is the negative part. Similarly, in other py, pz, px, and pz also similar things can be explained. The electron density of at node is 0. Here px, py, and pz are called degenerate orbitals. Degenerate means equal energy. So these orbitals have same energy, therefore they are called degenerate orbitals. Filling of atomic orbitals with electrons. This is basically done by following three rules. First, above principle, second, Pauli's exclusion principle, and third, Hund's rule. So what is above principle? According to above principle, the lowest energy orbital will be filled first. So here 1s will be filled first, then 2s orbital, then 2px, 2py, and 2pz. In this way, z. In this way, it will be filled. Now, the Pauli's exclusion principle. So, what does Pauli's exclusion principle says? Each orbital can accommodate a maximum of 2 electrons that have opposite spin. So, if say this is 1s orbital, so according to Pauli's exclusive principle, maximum 2 electrons can accommodate, and both having opposite spin. Now, Hund's rule. What is Hund's rule? When dealing with the degenerate orbitals such as p orbital, 1 electron is placed in each degenerate orbital first before other electrons are paired up. So, according to Hund's principle, say 1s, 1, 2s are already filled here. By above principle and Pauli's exclusion principle. Now the degenerate orbital p will be filled. How it will be filled? 2px, 2py, 2pz. So first all the orbital will have 1 electron. After that they pair up in this way. So this is the Hund's rule. Now we'll see an example how in elements following these three principles fill electrons in their orbitals. Fluorine have fluorine have uh, fluorine have at 9 electrons. So how it will be distributed? First, 2s orbital will be filled, then 1s orbital will be filled, then 2s orbital will be filled, then 1 electron will be distributed in each of the 2px, 2py and 2pz orbital. Rest of the electron will be again distributed here. So 2 to 4 to 6 to 8 and 9. In this way, fluorine electrons will be filled in different orbitals. Electronic configuration summary can be written as 1s2, 2s2, 2p5. Now pause your video and solve this problem, then proceed again. Now, valence bond theory. With the understanding that electron occupies regions of space called orbit, we can now turn our attention to more deeper understanding of covalent bond. Specifically, a covalent bond is formed from the overlap of atomic orbital. There are two common used theory for describing the nature of atomic orbital overlap: the valence bond theory and molecular theory (MO). The, the valence bond theory is more simplistic and is treatment of bond, and therefore we will begin to discuss with valence bond theory. So in the figure we can see the one electron is wave-like structure when comes nearer to another electron, same as wave-like like structure. Initially, the intermolecular distance was apart. Now, as they bring closer, the intermolecular distance here in the step 2 becomes smaller, and ultimately in these two waves reinforced with each other, and this type and form a constructive interface. So constructive interface produce a wave with larger amplitude. There is another theory called destructive interface. Here the waves are coming closer, and uh, ultimately destructive interface are formed. Here destructive interface the wave cancels each other and produce a node. So this is the difference between constructive and destructive interfaces. So according to valence bond theory, a bond is simply the sharing of electron density between two atoms as a result of constructive interface of their atomic orbitals. So let us take an example of hydrogen molecule formation. Here 1s of hydrogen atom, 1s orbital for one hydrogen atom comes closer to 1s orbital of another hydrogen atom, and ultimately 1s H2 molecules are formed, and here the type of bond which is formed is sigma bond by sharing the electron cloud density or electron density. Molecular orbital goes a step further, and according to the definition it says that molecular orbital are mathematical methods to combine to produce a new orbital, which is known as which is called molecular orbitals. The method for by which molecular orbital uh, are formed are the mathematical method by which molecular orbitals are formed are known as linear combination of atomic orbital, LCAO. So, according to molecular orbital theory, bonding MO and anti-bonding MO are formed. So, the lower energy molecular orbital was called as bonding MO molecular orbital and is the result of constructive interference of the original two atomic orbitals. The higher energy molecular orbital or anti-bonding MO is the result of destructive interference of the two molecular orbitals. So, hybridization. First, there are three type of hybridization: sp3, sp2, sp1. So first, let us discuss sp3 hybridization. Example is methane. So let us see what happens in normal uh, electronic configuration of carbon. So normally this is the normal case where one s has two electrons, then 2s has two electrons, and 2px has one, 2py has one, and there is no electron for 2pz. But as soon as it is excited, energy is increased here. 1s is unaffected, but 2 electrons are one of the electron out of two electrons are shifted here at 2pz, and rest of the structure remains the same. But one fundamental change had happened, that now carbon is have one vacant 2s orbital and three vacant 2p orbital. In this way, it is now tetravalent, and carbon have now four degenerated orbitals. Degenerated mean four orbitals with the same energy level. Therefore, this type of hybridization is named as sp3 hybridization because one s orbital is involved and three p orbitals are involved here. Few of the main properties of sp3 hybridization are these two are unsymmetry, not equal, and the shape formed is tetrahedron shape. They form single bond all the in the molecule, all the atoms form a single bond with each other, and as well as sigma bond. They form sigma bond with each other. The bond angle between the carbon and hydrogen bond is 109.5 degree. An example is methane. Methane, ethane also can be the example. So what happens to the carbon atom in the sp2 hybridization? So this is the energy. Now in this is 1s, so 2 electrons, 2s 1 electron, 2p, this is 2p, this is 2s 1 electron, 2p z 1 electron. In this case, as soon as it is hybridized, what happens? 1s2, this remains the same. So 1s orbital remains the same. So, but 2s orbitals and 2p orbitals are in hybridized state. So one which is in the box is not in hybridized state. So these three are in hybridized state. So one s among this, one s orbital is there. So sorry, 2s orbital, 2px, 2py are there. So the hybridization name is sp2 hybridization. In ethylene, carbon-carbon and carbon-hydrogen forms sp3, sp2 hybridization, and a sigma bond is formed by overlapping of electron cloud density. Beside this, two carbon atom in ethylene also have two p orbitals. So p orbitals also overlap each other to form a pi bond. So, so in summary, we can say that in ethylene, the carbon atoms are connected via sigma bond and a pi bond both. The sigma bond results from the overlapping of sp2 hybridization atomic orbital, while the pi bond results from the overlapping of p orbitals. These two separate bonding interaction sigma and pi comprise the double bond of ethylene. So let us see how sp3 hybridizations are formed. So here in 1s, in normal scenario, 1s orbital have 2 electron, 2s orbital have 1 electron, and in hybridized state 2p orbital have 3 orbitals, 3 electrons. And what happened? These these two electrons are unchanged, and this is unaffected. This 1s and so here upon hybridization, what happened? 1s is not affected, but here 2 one s orbital and one p orbital. So two degenerate sp orbitals are formed here, and the last one 2p, this doesn't participate, so this remains constant. So mainly hybridization which we are talking about, sp hybridization, is this one. Now if we compare the carbon carbon single bond, double bond and triple bond length and bond strength, then we found that the bond length in single bond is more than that of double bond, and double bond is more than that of triple bond, and bond strength is, in single bond it is less than that of double bond, and in triple bond is more than that of double bond or single bond. Vesper theory, full form is valence shell electron pair repulsion theory. So to know the Vesper theory, we have to first understand steric number. What is steric number? So the total sigma bond plus lone pair is called steric number. Means we focus on the central atom and count the number of sigma bond and lone pairs, and the total gives the steric pair. For example, in methane, total number of sigma bond is how much? Of sigma bonds is equal to 4. Total number of lone pair is equal to 0. Total, so steric number is equal to 4. Similarly, in NH3, if we want to see NH3, total number of sigma bonds is equal to 3. Total number of lone pair is equal to lone pairs is equal to 1. So steric number in this case is also 4. The steric number indicates the number of electron pair bonding and non-bonding both that are repelling each other. The repulsion causes the electron pair to arrange themselves in three-dimensional shape. So the so to achieve maximal distance from each other. As a result, the geometric shape of the central atom will be determined by the steric number. This principle is called Vesper theory. So we can see that in methane and NH3 we have steric number as 4. So arrangement of electron pairs is tetrahedral, and geometrical shape for methane is tetrahedral, but the geometrical shape of NH3 ammonia is triangular pyramidal. Here let us take an example of nitrogen in amine. So here We have number of sigma bonds is equal to 2 number of lone pair is equal to 1. Therefore, steric number is equal to 3. Therefore, the geometry is trigonal trigonal planar. Now, geometric resulting sp hybridization. Let us take an example of carbon dioxide. From the structure, we can see the sigma bond number of sigma bond for carbon atom have 2, because pi atom are not considered in steric number. In the calculation of steric number, only sigma bonds are considering, so we have 2 sigma bond, and therefore the steric number is 2. Therefore its shape is linear. Now let us summarize the steric number, hybridization, shape, etc. So if the steric number is 4, if the steric number is 4, then the hybridization is sp3, and tetrahedral arrangement of electron pairs are found. In that, 3 cases can be there. Form 1, no lone pairs. In that case, the shape is tetrahedral. Second, 1 lone pair. In that case, trigonal planar, and 2 lone pairs. In that case, bent. The shape is bent. Now, if the steric number is 3, then the hybridization is sp2. The arrangement of electrons pair are trigonal planar. In this case, two case can be, we can have first no electron pair, then the shape is trigonal planar, and one one lone pair, then the shape is bent. The third type, if the steric number is 2, hybridization is sp, shape is linear, and there is no cases. The shape is linear always. Now, please pause your video and solve this problem. And once completed, then only move forward. For today, we are closing this session. Please subscribe, like, and share our channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded. Please write any problem in the comment box, and any video if you want will prepare for you, and all the sums, the numericals for organic chemistry today what you have done. If anything, any problem in those numericals, please write in the comment box. We will solve for you. Thank you very much for joining the class. Thank you for supporting us.